as the lower and the upper.
Okay, lower and the upper.
And you don't have to do the calculations. You don't want to. I mean, I'm happy to do them all day. They're very intense here.
Okay.
Um, just checking
Yeah,
that
I
I
was
got
gonna.
everything in there.
Okay. Alrighty. And then. Mm, okay.
All right, so it did take that.
Yeah,
All right,
it did
that's
take.
good.
So this is where kind of got
Understood.
some of it right. Should I try another
Okay.
one or should I just leave it?
We can A, null hypothesis is incorrect. Uh, you'll have to scroll up. So
This is the one
can
I
you
got
read?
right. Huh?
Oh, I see. Yeah, why don't you redo it and we'll
Okay. So
you can redo it.
yeah. See.
Yeah. Yeah. Okay, let me just grab a couple of snips.
I noticed there's like on this though, on this homework, there's a lot of these on this homework.
Say that one more time. I didn't quite catch that.
On this homework on the child, like on topic 6, there's a lot of like these type of questions on this one.
Okay. Yeah. Yeah, you're full into the whole like hypothesis testing, and
Yeah.
this is the heart of the course, if you will. Right. The okay, so the words here 225, 265, those are the samples. And the okay, so we got kind of the same deal. N1, X bar 1, sigma 1. Yeah, sigma 1. Okay. So it's 225, N2 is 265. N1 is 78.3. Sigma 1 is 7.9. And then 76.9. And then sigma 2 is 6.6. Okay. Now the we want to know that the completion time mu1 is greater than that of so mu1 greater than that of the mean of mu2. Okay. So that's H1, which is mu1 greater than mu2. That's the claim. Claim always goes in the alternative.
Okay.
And then based on what we saw in your previous homework, let's say it's mu1 equals mu2. It's a z because of this word where it says assume that the population standard deviation can be estimated from the sample standard deviation. That's why it's a z.
Okay.
Because they're saying, hey, we know that. Okay, to find the test statistic, that's the most work here. To actually find the z, it's 78.3 minus 76.9 over the square root of 7.9 squared over 225 plus 6.6 squared over 265. And this should look really familiar to the confidence interval
Yeah.
calculation we just did. It's essentially the same one. It's x bar 1 minus x bar 2 over sigma 1 squared over n1 plus sigma 2 squared over n2. All right, so we got to do that calculation. All right. So I get 2.106 for that one. So that's part C. For part
Okay.
D, helpful to draw the normal curve here. 2.16 is over here somewhere. We want the area to the right of it. So you can get that from table, computer, uh, pH 2.106. And let me get that value. It's been pretty small because it's to the right there. So it does it say 4 decimal places?
It says 3 or more.
Three or more. Okay. I don't know what the 3 or more. 0.0176. 4 is kind of the standard.
Oh, okay.
And then can we support the claim? So you're trying to decide here, is this less than the p-value? Or I'm sorry, is this less than the alpha? The alpha is 0.05. So since 0.0176 is less than 0.05, you reject H0 and you support the claim. So yes, we can. Hopefully that works out a little better than the last one.
Everything's right, but I must be entering my A wrong. Hold on, let me just fix. I think it's the U. So let me just fix. Yeah.
It might. Okay, hang on. Yeah, let me. Your null hypothesis. We should. So the traditional thing is for mu1 to be less than or equal to mu2, and sometimes they want them on the same side of the equal sign. So like in other courses I've seen, it's like mu1 minus mu2 equals 0.
Okay. I think. Hold on. Let me just try this really fast because I had the U messed up.
Okay.
There we go. Because I put a normal U instead of this U. Okay. So then the next one. What is another one of these?
Okay. So this one is grab this question. Okay. Clear my screen. Okay. Show mean of 91. Okay. So this one has a different language and it says here, assume that the population scores are normally distributed and the populations are equal. Okay. So that's a different formula than what we've been doing. It's still this N1 X bar 1, but now it's S1, N2 X bar 2, and S2. So we have 13, 92, 15, 9, 118, 13. So this time it's a 99% confidence interval. That means alpha is 0.01 and the alpha divided by 2 is 0.005. Now I just got to ask here. I mean, did you get oh yeah. Could you could you share your screen again for that list of formulas? I need to grab that.
Yeah.
All right, scroll down. Way down. Keep going. All right, right to right. This is the one there where it says unknown sigma 1 and sigma 2.
Okay.
But we know it's the one in white there. This is the most difficult one to do. Oh boy. Yeah. Could you scroll down a little more?
Yeah.
Keep going. Yeah, keep going.
Yeah.
All right. So actually, scroll up a little. So yeah, go up a little more. Sorry, it's the one above the yellow there.
That one.
Yeah. So believe we're using this formula here. The issue is that I I don't know what the degrees of freedom calculation is. I'll have to look that up. But okay, go ahead and I don't know. So most students end up doing this all in software, and you're being asked to do it by hand, which is kind of awful.
Yeah.
But the first thing you have to do is calculate this this SP2 from this data set.
Okay, so that's when
And
the S comes in place.
S2P is going to be 13 minus 1 times 15 squared plus 9 minus 1 times S2 squared over 13 plus 15 minus 2. So we're going to first calculate that. Okay. So, and then when we get that number, we're going to take the square root of S2P 1 over 13 plus, sorry, this should be a times 1 over 15. And then we need the degrees of freedom because of the t distribution. It's 13 plus 15 minus 2, which is 26. And so then we have to look up in the t table, t 0.005 comma degrees of freedom 26. I apologize if this is unclear, but this is the steps that are needed. T dot distribution. All right, so inverse left tail. Okay, 0.005 comma 26. All right. So this is so then we're going to use this 2.779 number out in front, and then x bar 1 minus x bar 2 over here on the left is 92 minus 118, and then plus or minus this. So it's a lot there.
Yeah.
So I'm gonna work through this here in case you want the intermediate values, but let me get where I can do this. 13 plus 15 minus 2. All right. 15 minus 1 times 15 squared plus 9 minus 1 times 13 squared. All right, so for this S2P number, I got 155.85. That's rounded. And then for the rest of this, I'll do so I got minus 39 point. How many decimal places do we round to? 3? 2 decimal places. All right. All right, minus 39.15, comma, minus 12.85. We'll give those a try, see if we're in the ballpark. Reasonableness.
I'm sorry. This is so the 39.15 was for the lower limiting.
Yes, yes.
Okay, and then the
Negative 39.15, and then minus 12.85.
is for the upper limit.
Yes, yes.
Okay, I entered that and it said it wasn't reshowing.
Okay, could you share your screen? And this may be a case where I need to, you just have to try that again, and then it'll show us the right formula, and then we can do it. I can figure out why it's not taking it. And that's
For sure.
kind of
Hold
a,
on.
sure,
Let me do it again so we can see. I'm gonna have to do it one more time.
that's okay.
Okay.
That might be a strategy going forward is to like, um,
Hmm.
does it show you the work?
Well, on here, like on the side right here, like this is what I've been using, but like it's like it's so much, like I get confused with it.
Yeah,
I
yeah,
guess.
that's what I was looking for. Okay, so that's what we used.
Uh huh.
What did I do wrong? What did I do wrong? 0.005, 28 minus 226. Okay. Yeah, keep going down.
Yeah.
Um,
Yeah. So this is where I was getting thrown off too.
yeah, I mean, it all looks okay to me.
Uh-huh.
Meaning, like we've got the same values. It's not like, all right. I mean, I can just retry it here if you're
No,
okay with that.
it's okay. We can just move
It's
on.
the same formula that I was
Uh huh.
using. It's just,
But then I
I
think
don't
there's
know.
more. I think there's more like these type of questions going on. I mean, but if you could do it again if you want to.
Yeah, we can do it real quick and,
Okay. We'll try
hopefully,
that.
all right. So just keep your screen up.
Okay.
13 and 9 again.
Oh, it's different this time. It's the 90 instead of 99.
Yeah, and that changes one of the values. It's always good to like be on top of that. 8.07. All right. That number seems really small. Squared plus that number times that number squared. All right. So then we have 62.5 minus 54.6. And then I gotta get that value. So this time it's a 0.05. And we have, oh, that was the issue. Now I see the problem. Okay.
Okay.
Why did I do that? Huh. Okay. 13 and 9 is the sample sizes, right? Yeah, 13 and 9. It's 22 minus 1. Okay. 1.725. So it was my fault in the last one. I used the wrong values for the sample size, which is what caused the issue. It's because there was this duplication in it. And
Put it
oh man,
off. Okay.
13 plus 9, a little better. And then, all right, so I guess try these 1.91 for the lower limit
Mm, okay.
and then 13.89 for the upper.
Mhm. Correct.
Okay, all right.
Now it's back with the 99 one.
99. Assume
And
that the
then
two
we
population weight gains are normally distributed with population mean amount. P2, carry out. So this is the same calculation as the previous one, except they're
have,
giving you variance instead of standard deviation, which is okay.
okay.
Um, Do you want me to run through the calculation on my own, or do you want me to share my screen? What would be best for you?
Um, it doesn't. It doesn't matter.
Okay.
I want to see how you do it actually. So when I do take the
Okay.
test, so I take the
Yeah,
test. I know it's
right.
gonna get longer, but
That's why, yeah, that's why I'm asking is you're the customer. I'll make sure you get what you want out of today's lesson. So,
okay,
all right,
yeah,
let me share my screen.
because it does help. Because when I take the exam, I'm like, oh, I
Yeah.
remember doing this.
All right. So the issue was last time is that is that I wrote down everything correct, but I didn't use the correct values in the formula. So try to do better here. So we have 14 people, N2 is 13 people, 9.91, X bar 2 is 13.59. Oh, sorry, variance. That's the difference here, 13.59. That's a big difference there. It's giving you the variance, not the standard deviation. And then that's 6.51. S2 is 1.32. Okay. So we have to do this SP calculation. This SP squared is N1 minus 1 times the variance. So I'm not squaring this one because it's already squared.
I see.
Plus 13 minus 1 times 1.32, same thing. And then that's where I made the mistake last time. It's N1 plus N2 minus 2.
Uh-huh.
Okay, so we got to get this number. Then we have to get our confidence interval. So the C, like you said, is 0.99. Alpha is 0.01. Divided by 2 is 0.005. Our degrees of freedom is 14 plus 13 minus 2, which is on the bottom there. So this T value we're looking for, this is where you have to look this up
Okay.
uh, in a table or use software. That's where I thought I'd originally gone wrong with the first calculation, but it was actually just using the wrong numbers. 2.787. So our confidence interval is X bar 1 minus X bar 2 plus or minus the T value 2.787, the square root of this SP squared number times 1 over N1 plus 1 over N2. So you would first calculate this SP2 number, go out to a bunch of decimal places, and then using this formula here. All right, so 14, 13.59, 13 minus 1, 1.32, and there 14 plus 13 minus 2. All right, so if you do this calculation, you get about 7.7004, and then I'll use it in the next calculation, 9.91 minus 6.51, 2.787, square root of that SP number we just found, 1 over 14, 1 over 13. All right, so the lower bound here, how many decimal places? 3 or
Two.
found 2 or more decimal places. All right, 0.42 is the lower bound. And then the upper bound is 6.38.
That's good.
Give those a try.
Yeah. Do it. See my screen here.
Oh no.
Yeah.
Oh, so all right. So population and the population variances are equal. All right. So the difference between this problem and the others is that you have to calculate the mean and you have to calculate the standard deviation, which is more work. And that's why it says send data to calculator, send data to Excel, because no one does this, by hand. I mean, it's just horrible. Could you just scroll down a little bit so I can get A through E, or if there's another one? That's it. Okay. All right. So do you use Excel? Are you familiar with Excel?
Yeah, I've used Excel. Yeah.
Okay, fantastic. So what
So
I'm
do I?
going to do
Oh, okay.
is, I'm going to open up Excel, but not share that.
Uh-huh.
And I'm going to enter those data values into
Uh-huh.
Excel, and then I'm going to calculate the mean and the standard deviation of each data set, which is a basic built-in calculation here. So most of the mistakes are made just entering the data, which is why they give you the option to copy and paste there. So
Mm.
just keep that in mind. 12, is that 12? How many data values do you see there? 12,
Yeah,
69.
with this math, like my other math course, we used a lot of Excel in math,
Oh, cool.
and this
Okay.
one we use like none of Excel. It's all in
Yeah,
here.
and I'm happy to show you how to do all these in Excel if you need
Mhm.
that. But okay. So equals the average. So we'll do that for data set one, data set two. All right. So N1 is 12, N2 is 12. X bar 1 is 72.25. X bar 2 is 72.8, and then 3 repeating. So I'm going to go out a little bit further on that. And then S1 is actually I'm going to give you the variance, so it'll be like the last one.
Okay.
Um, because that it won't round as much. But you want to use the variance of the sample, not the population. So it ends up being 12.023. S2 squared is 5.424. Okay. Now some of this we can answer, and this should help you for the rest of the assignment because I'm probably not
Mhm.
get to everything, but the first stuff you don't actually need like any calculations for. So it's always the null at the class is always on mu, that Greek letter mu. And then we want to know uh different. Different means not equal to. So mu1 not equal to mu2, and then mu1 equal to mu2 there. This is a t-test. It's a t-test because we don't know the standard deviation, the population standard deviation. So our t value, our t is, and this is kind of the nightmares. You have to do this SP2 again.
Yes. So well, that's fun one.
Yeah. Um,
At least I know
it's
now what to calculate when I'm going on it.
yeah. 424 over 12 plus 12 minus 2. So your t is x bar 1, so 72.25 minus x bar 2, which is 72.8333 over square root of SP squared 1 over N1 plus 1 over N2. All right, so let me get some of those values. Well, 12 minus 1, 12 plus 12 minus 2. So that ends up being 6.6715. And then dividing by 1 over 12, 1 over 12. Oh, I used the wrong numbers. All right, so the answer here is, oh, p-value is not large, minus 0.5532. So let me just check one thing. I always worry that I didn't enter the data incorrectly and that would throw everything off. 75, 73. So I read the data set backwards to check it as a way to like make sure that I'm not just mentally biasing myself that I did it correctly. So I look at it backwards when I check and it seems to work out. They say to do that when you're reading papers. I find that really hard to do.
Never heard of that.
Yeah. Yeah, I don't know. I don't all
Something to
right.
try.
Something to try. All right, so that looks okay to me. So in terms of the p-value, it's minus 0.5532. But because it's two-tailed, because of the not equal to, you want the area in both of these tails. So you
Mhm.
end up doubling whatever you get here. So I'm going to do that now. P dot distribution dot minus 0.5532 degrees of freedom is 22 true times 2. All right, so the p-value I get is 0.5857.
Hold on just 1 second. So for like the B, for part B, when I put T, it gives me like this thing on the side where it says degrees of freedom.
Yeah, so the degrees of freedom is 12 plus 12 minus 2, which is 22. It's always the denominator here. So the reason we cannot conclude that there's a difference is that p-value is so high.
Yeah.
All right, so whenever you're ready, if you want to share your screen, look at another problem, just step away for 5-10 seconds. I'll be right back.
Yeah. I think about the extra stuff on, so go ahead.
All right, so what are we looking at here? Was there an issue or
Oh, yeah. A and let's say like unfit stuff on.
should variances are equal? Yeah, I don't know. C and D. I don't know because it may be that
It's okay. I'll go back to it.
I really don't know. I would always like if you said, "Hey Matthew, I just need the answers," I would go to some software and make sure you got the full answers. But doing it by hand, I mean, I don't know. Uh,
No, yeah, no. It's okay. No worries.
let me check. Hang on one more time. Let me just check one more thing.
Okay.
12 plus
It's
12
just the
minus
more of
2.
like the explaining it of the thought process. So then when I do go by myself, then I understand it more.
Yeah. 72.25 square root SP 1 over 12 plus 1 over 12. So the answer, like D, if you get C wrong, D is going to be wrong, which is why I'm looking at that calculation one more time here. I am not seeing it, which I do hate because we should be able to get it. 9.72.25, 72.833.
And it
Three.
is confusing. So it's
Yeah,
a little
I'm sorry.
tangled.
I don't see it. So if you
No
want us to
worries.
move on to another
We
one,
should
we
move
can.
on. Yeah, for sure. Like it's in and there's like more of them. So let me see if I can find a different one of the up. This is the upper and the lower one.
Right.
I wanna or take like this one right here. The upper and the lower. This one.
This one's actually better. These are easier than the other ones, believe it or not. Even though maybe
Oh,
it looks more complicated. Uh, because it's a difference,
uh huh.
And I'm going to share my screen
Like
here. So
these were the
you
ones more or less that I was struggling with. Like the other ones, I was like kind of more or less getting like half of them correct. So
well,
I'm okay.
you actually only care about this right here. And this is now just a t-test, which is pretty nice. So you have to find the number of samples, which is 14, the mean, and then the standard deviation of it, which isn't bad at all. So I'm just going to enter those data values into my spreadsheet here
Okay.
and get those numbers. And what I can't remember is whether the degrees of freedom is n minus 1 or n1 plus or n minus 2. So I'm going to look that up because I always do this in software. I never have to actually go in
By hand.
and figure it out because like why would you? So let me just do a quick check
Mm-hmm.
on that. Um, paired test degrees of freedom. It's n minus 1. Okay, so the degrees of freedom here is 14 minus 1, which is 13. And then the average here that I got is minus 32.5. And then standard deviation is 86.191. So the confidence interval is minus 32.5 plus or minus. So you have to find this t value. So it's 0.005 comma 13. We're looking for that value there. 13, and that's 3.012 times the standard deviation, which is 86.191 over the square root of 14.
I could find that like T chart you're talking about online because I found the Z chart you were telling me about.
Yeah, it's online. It's if you're allowed to use a calculator, it's a little easier to find. Um, but let me get the calculation for you. That is kind of a big difference. All right. All right. So the calculation, two more. All right. So we got minus 101.88. That's the lower bound, comma 36.88 is the upper bound.
Yes. I'm gonna see if I can find another one of the upper and the lower ones because those are the ones I was mostly struggling with. Oh, can we give this one a try maybe?
Yeah, of course. Um,
Mm,
all right. So the short of this is that it's going to be, oh no. Okay, server one. All right, so these are independent samples. So the way that I know that is that it says uh, that server one did not affect server two. If you see that kind of there in the last sentence.
all right.
So they're independent samples. Now, the thing that okay, we've got to read this down in part B. Part B, I'm not sharing my screen yet, by the way. Assume that both populations are approximately normally distributed and the population variances are equal. So that's the same formula we've been using with that SP stuff.
Nice.
Okay. And so this is going to be a T test. All right. And that's that you have to like glean all that from just reading this, you know, thing. And this is really important to do. I mean, like if you know, if you really wanted to compare performances of people, but
Mhm.
um, yeah, that's so this is the X bar, this is the S, and then N is 12 and 13. So we have to find that we have to find that T value again. So that SP squared is that same thing. 12 minus 1, 7.071 squared. I run out of room here. So let me move this over. Plus 13 minus 1 times 7.351 squared over 12 plus 13 minus 2. And
Mhm.
then your T value is the difference in the sample means 40.405 minus 37.757 over the square root of SP 1 over N1 plus 1 over N2, like that. All right, so let me quickly calculate those as quickly as I can without making a mistake. 13 minus 1, 7.351 squared, 12 plus 13. All right, so the SP value ends up being 52.106. And then the P value here, 40.405 minus 37.757 divided by the square root of that SP, 1 over 12 plus 1 over 13. Easy to get parentheses in the wrong place. 0.9164 is my P value there.
Mm. All right. I don't know if you want to go out with another one or should
We
we
can
stop?
try. We can
Okay.
try. I mean, I
Yeah,
can
I
maybe get you
I found
started or
another. I found another in the lower and the upper one.
okay. Yes, this is proportions, which is different than anything we have done thus far.
Oh,
Could you grab the formula sheet for us, please? The list of formulas and scroll
oh,
down to the ones that have P1 and P2.
you
Uh,
want?
yeah, you're gonna go way down, keep going way down. Right there. Okay, right there. So there you go. That's the two formulas. You got the confidence interval and then the thing there. And, oh, but it looks like truly it looks like it's missing some formatting. I don't know, maybe it's a browser issue. I don't know, but
I
nevertheless,
mean,
here
yeah.
we can do this. So for confidence interval, all right. All right, so P1 is N1. I'm sorry, it's what's called X1 over N1. It's uh 224 over 350, and P2 is 171 over 300. I'm getting at from these numbers here.
Uh-huh.
Okay. Now, to find the constant interval, this is always a z. These are always z's, and you need the c. The c is 0.95, so the alpha is 0.05 divided by 2, which is that 1.96. So it's P1 minus P2. It's the 224 over 350 minus 171 over 300
Mhm.
plus or minus 1.96. That's the z alpha over 2. And it's the square root of basically it's this thing here.
Okay.
Okay. And these are your hats, if you will. So it's a little cumbersome to like write because it's a lot of fractions, but you have P1 you have N1, N1 is 350. You have P2, you have N2. So it's just a matter of putting this into a formula. So let me do that here really quick to save you the headache here of doing this on your own. P2 is 171 over 300. If you do, oh, these actually worked out nice, which I didn't expect. 0.64, 0.57. So it's actually not that bad. It's 0.64, 1 minus 0.64 over 350 plus 0.57, 1 minus 0.57 over 300. And then you do go ahead and calculate these. So give me just a moment here to get these two numbers. Minus 1.96 times square root P1 times 1 minus P1 divided by 350 plus P2 times 1 minus P2 over 300. All right, so it's minus 0.0053 comma. This is not unusual for them to be really, really small values to 0.1453. So give those a try and let me know how that goes for next time.